So doing a stretch or a compression focusing on y is fairly easy just because you're multiplying y times whatever the value is, you get your new point and move on. When you're using x, a horizontal stretch or reflection, it's a little bit more difficult. So example 2 is asking us to do that. We know that they're asking us to do a horizontal stretch or compression because when they give us the new equation, the number is on the inside of the function. See, there's the f, it could be a g, it could be an h, whatever, but if the number is on the inside of that function, then that's going to be applied to x. So we remember from our handy-dandy cheat sheet that what we're looking at here as a pattern is x over b, and y stays the same this time. Now b, in this case, is -3. So we're just going to put a -3 here, and when we make our new set of points, we're just going to take our x value and divide by 3. So I'm going to write the first one out, and then we're just going to fill them in. So my new point is going to be -6, because that's my x value, divided by -3, and -4 just stays the same. So my new point is going to actually equal -6 divided by -3, which is 2, and -4. So that's going to be my new point. I'll just make a little arrow here so you know that it went from there to there. Now I'm just going to fill in these ones. -3 divided by -3 is going to give me 1. 6 stays the same. 3 divided by -3 is going to give me -1. 4 stays the same. 6 divided by -3 gives me -2. -2 stays the same because the y is just going to stay the same. Now when we plot these points, we're going to plot them -2 and -2. Should be here. -1 and 4. So -1 and 4. Just going to move my 4 there. 1 and 6. And my last one is at 2 and -4. So I'm over here at 2 and -4. So when I connect these, good enough, you can see two things. First, this is a whole number, and so it's been compressed, because when we are dealing with a whole number and x, there's a compression. And we also see that the high point on the original graph was on this side, and now it's on that side, which means that we've had a flip over the y-axis, which from 3.2, you'll remember if the negative is inside the brackets, inside the function, then we're going to have a reflection over the y-axis is what we have. So, not that much more difficult. You just divide instead of multiplying, but it is something important to keep in mind.